All right, so have you ever tried learning something new? Like a new skill with someone kind of looking over your shoulder?
Yeah,
Can be a little intimidating, right?
for sure.
But like, what if that someone was like a robot expert and they were guiding you, but in augmented reality?
Oh, wow.
Yeah, we're going to dive into some research today that did exactly that.
Okay,
And the results are really, really fascinating.
cool.
So they looked at how using AR, especially when you're working with someone more experienced,
Right.
can impact how much you trust a robot.
Yeah, what's really cool about this research is it's not just about trusting robots in general.
Mm-hmm.
It's about how we actually build trust when we're collaborating with them,
Right.
like in a shared environment.
Yeah, and to do that, they use this idea of shared mental models,
Yeah.
which is like key for any successful team.
For sure.
I mean, think about it like this.
Okay.
You and your teammate, you're both looking at the same blueprint.
Right.
You both understand what each symbol means, where everything goes, how it all fits together.
Yep.
That's a shared mental model.
Makes sense.
It's about being on the same page.
Exactly. And in this case, they wanted to see if using like a multi-user AR interface
Right.
could help build that kind of shared understanding between a human and a robot.
Yeah, especially
For sure, when the robot isn't always perfect.
not perfect, right?
Yeah.
Well, so to test this out, they used a Boston Dynamics Spot robot.
Oh, cool.
You know, those like agile four-legged robots.
Yeah.
Paired it with Microsoft Holland's headsets
Okay.
to create like a shared AR space where people could interact with the robot,
I see.
both individually and in pairs.
I see.
Now, the important thing here is
Yeah.
everyone's got to see the same virtual world and it's got to be in sync with the real world.
Right.
So they used some pretty clever tech that acts like a common reference point for that whole AR experience.
Okay.
Now, they didn't just kind of throw people into this AR world with a robot and say good luck.
Right.
They designed a specific interface with some really cool features
Okay.
that make interaction and training more intuitive.
What?
So, for example, there were these visual cues that would highlight potential issues.
Okay.
Like something called a drift sphere,
Sphere.
which showed how much the virtual and physical spaces might be misaligned. It's like a little reminder that things aren't always perfectly in sync.
Right. Because the real world and the virtual one. they're-
Exactly.
Yeah.
They also included a really neat voice command
Oh,
called select.
okay.
And this is cool because it let the user physically demonstrate the pose they wanted the robot to take.
Interesting.
So instead of typing in complex commands,
Right.
you could just show the robot what to do. Like teaching by example.
Yeah, but in AR.
Yeah.
That's cool.
To make things even more precise, they had a virtual go-to marker.
Okay.
Like placing a target for the robot to reach.
I see.
And all of this was designed to make controlling the robot as natural and understandable as possible.
Yeah, so you want to lower that barrier to entry and make it,
Yeah, exactly.
as intuitive as possible.
Now, one of the things I thought was really cool about this study is
Yeah.
they didn't just want to see how people interacted with robots. They wanted to see what would happen when things didn't go exactly as planned.
Right. So they wanted to see how people would react when,
Right.
things got a little messy.
Because robots aren't always going to be perfectly predictable, are they?
Exactly. So they intentionally introduced some what they called erratic behavior
Right.
into the robot.
So it wouldn't.
So sometimes it wouldn't go to the designated spot,
Right.
or it might follow the user unexpectedly.
Yeah.
They did this to see how trust was affected when the robot didn't behave as expected.
Now, before we get into how people reacted to this unpredictable robot,
Yeah.
let's talk about how they actually measured trust in the study.
Okay. How'd they do that?
So they used something called the Reliance Intention Scale,
Oh, interesting.
or RIS.
RIS.
And this is designed to measure the different ways we trust robots.
Okay.
It's not just whether we trust them or not,
Right.
but also looks at how much responsibility we're willing to give them.
That's a really important distinction, and it ties into those different levels of trust
Right.
we were talking about earlier.
Yeah.
Like the RIS scale, it distinguishes between relying on a robot, which is kind of like having it assist you.
You're still in control.
You're still in control,
Right.
right? Versus delegating to a robot,
Okay.
which means giving it full responsibility for a task.
Okay, so we've got this cool AR setup.
Yeah.
We've got the inspection task.
Uh-huh.
We're intentionally making the robot act a little flaky.
Right.
How did people's trust hold up under these conditions?
That is the question.
That's what we want to know.
So they divided the participants into 3 groups.
Okay.
Group 1 worked with a highly reliable robot,
Okay.
the kind that always does what it's supposed to.
Perfect robot.
Yeah.
Okay.
Group 2 worked solo with the less reliable, sometimes erratic robot.
Okay.
And group 3, this is where it gets really interesting.
All right.
They had pairs of users, one novice and one expert,
Okay.
working together with that same unpredictable robot.
So group 3 is where that concept of shared mental models and learning from an expert really comes into play.
Precisely. And the results of how these 3 groups reacted to the robot, well, that's what we'll dig into next.
That's what we're going to find out. It's like the difference between trying to figure out a new gadget by yourself versus having a tech-savvy friend show you the ropes.
Totally.
Like that shared experience.
Right.
It just makes a world of difference, especially when you encounter those like inevitable hiccups.
Exactly. And that's precisely what they found in this study.
Oh.
That presence of an expert in that shared AR space.
Right.
Someone who understands the robot's quirks and can guide the novice user.
Right.
Had a huge impact on trust.
It's really fascinating how they introduced that element of uncertainty with the erratic robot behavior. Right. It really makes you think about how we build trust in the real world, not just with robots.
Yeah, for sure.
You know, we're constantly evaluating, reassessing, adjusting our trust levels based on, you know, our experiences and the information we gather from others.
Think about it. You're working with a robot and it's behaving erratically. You might start to question its capabilities, doubt your own skills, even lose confidence in the whole system. But if you have someone you trust, someone with experience right there with you in that AR environment saying, hey, this is normal, it's just part of the process, that can totally change your perception.
It's like having a mentor reassure you.
Totally.
That you're on the right track even when things get a little bumpy. And in this case, that mentor just happens to be guiding you through this shared AR experience.
That's right.
And I'm curious about the results. They had those 3 groups. One with the perfectly reliable robot, one with the solo user and an unreliable robot, and then one with a pair of users and the unreliable robot. How did their trust levels compare?
Well, as you might expect,
the
people who worked with the reliable robot generally reported higher trust.
Okay.
But here's the really fascinating part.
The
trust levels in the group with the paired users and the less reliable robot were much closer to the group with the perfectly reliable robot than to the group with the solo user and the unreliable robot.
So even though the robot wasn't perfect, that shared experience of working with it in AR alongside an expert seemed to boost trust levels significantly.
And that really highlights the power of shared mental models and collaborative learning.
It's not just about the technology itself. It's about the social context in which it's used.
Exactly. And I think this has really profound implications for how we design and implement these human-robot interactions in the future. If we know that these shared experiences and expert guidance can really enhance trust, we can create systems that specifically facilitate those types of interactions.
It's like shifting our focus from like me and the robot to we, the human-robot team.
A team, exactly.
Recognizing that robots aren't just tools, they can be partners, teammates that we can learn from and trust.
Exactly. And I think that AR multi-user interfaces could be the key to unlocking that potential.
You know, one thing that I thought was really interesting about this study is that they intentionally kept the photo-taking task separate from the AR interface. They could have integrated it, but they chose not to.
Yeah, I think it goes back to the core focus of the study, which was really on understanding trust in the context of these shared mental models. So by keeping the photo-taking task separate, they were able to isolate the trust-building aspect of the interaction.
So it was all about?
It was all about how the users perceived and interacted with the robot in that shared AR environment, not about how good they were with the camera.
So they were very carefully controlling the variables to make sure they were measuring trust specifically related to the robot's performance.
Exactly.
And that shared AR experience, not other factors.
Precisely. And they also made a point to inform all the participants that they were interacting with experimental technology that was prone to errors.
Which is important.
Yeah, this helped set expectations and acknowledge that things might not always go perfectly. Like, we're all in this together, learning and adapting as we go.
It's interesting that they didn't specify the types of errors beforehand, so they let the participants experience them firsthand, and then observed how that presence of an expert in that shared AR space influenced their interpretations.
Exactly. It was all about observing how those shared experiences shape their understanding and ultimately their trust in the robot.
Now let's shift gears a bit and talk about what this all means for the future.
Okay.
Where do we go from here?
Yeah.
What are the real-world applications of these findings?
Well, I think this research opens up a ton of possibilities.
Yeah.
I'm thinking like healthcare, manufacturing, even disaster response.
Yeah.
Imagine like training surgeons on new robotic surgical systems.
Right.
Or guiding technicians in complex repair tasks. Or even helping people learn to use assistive robots in their homes.
Yeah, the potential is huge.
It is. It really is. And it's not just about the specific tasks.
Right.
It's about fundamentally changing how we think about human-robot collaboration. It's about moving beyond robots as just tools and embracing them as partners.
Right.
As teammates we can learn from and trust.
Speaking of trust,
Yeah.
you mentioned earlier that the study used the reliance intention scale.
Right.
Which distinguishes between reliance and delegation. I'm curious to hear more about that distinction. Why it matters in this whole context of human-robot interaction.
That's a great point to bring up.
Yeah.
It really speaks to the complexity of trust, especially when we're talking about robots.
Right.
So reliance in this context is about depending on the robot to do something correctly while you're still overseeing the process.
Okay.
So you're relying on the technology.
Yeah, it's like trusting your navigation app to get you to your destination.
Exactly.
But you're still paying attention to the road signs, the traffic signals.
Right, you're not just blindly following it.
Right.
Right. Delegation, on the other hand, is about handing over full responsibility for a task to the robot.
So that's like setting the navigation app and then taking a nap in the back seat.
Right, which I have to say probably not the safest idea.
Probably not the best idea.
But the point is that both reliance and delegation involve trust, but they represent different levels of trust.
Right.
With delegation requiring a much higher level of confidence in the robot's autonomy.
So what did they find in the study
Yeah.
regarding these two aspects of trust?
Yeah.
Were people more willing to rely on the robot or to delegate tasks to it?
Interestingly, they found that participants were generally more willing to rely on the robot than to delegate tasks to it.
Yeah, so even when we're okay with the robot helping us out, that jump to like giving them full control, that takes a lot more confidence.
It does, and I think that's really where the power of these shared mental models really comes into play.
Yeah.
When you have that shared understanding of how the robot works, you know, what its limits are, how to interpret its actions, you know, it really deepens your trust in it.
Makes sense.
It's like, you know that feeling you get when you've worked with a human teammate for a long time?
Right.
You just instinctively know how they're going to approach a problem.
It's less about like blind faith.
Right.
It's more about...
It's informed trust.
Yeah, informed trust.
Yeah.
Built on those shared experiences and understanding the robot's capabilities.
Absolutely. And I think that has implications like far beyond just human-robot interaction.
Right.
Think about any technology that requires us to place our trust in it, like self-driving cars, medical devices, even like the algorithms that manage our finances.
Right.
You know, the more we can create those opportunities for shared experiences, for transparency, for developing those shared mental models, the more likely we are to foster the trust that's needed for these technologies to really benefit society.
It's not just about making the tech more reliable, but making it more understandable. Get people the tools and experiences they need to confidently share control.
Absolutely. You know, this research really got me thinking about how trust in technology has evolved.
Yeah.
Like it used to be, we relied heavily on technical specs and expert assurances to determine whether something was trustworthy. But now it's becoming more about those shared experiences.
Yeah, right.
Collaborative learning, those social dynamics that shape our understanding and perceptions.
It's like we're moving from a world where trust was dictated by like authority to a world where trust is earned through transparency and shared understanding.
That's a great way to put it.
Yeah.
And I think AR and other immersive technologies are going to play a big role in that shift.
For sure.
Imagine a world where you can step into a virtual environment and experience firsthand how a self-driving car makes decisions.
Oh, wow. Yeah.
Or, you know, see how a medical device interacts with your body.
It's like demystifying the tech.
Yeah.
Giving people a window into its thought processes so they can feel more confident about sharing control.
Yeah. And the more comfortable we become with those perspectives,
you know,
the more we develop that shared mental model of how these technologies operate, the more likely our trust in them is to grow.
This has been a really incredible deep dive.
It has.
We've explored the intricacies of AR, the power of shared mental models, and the evolving nature of trust in a world where tech is becoming more and more a part of our lives.
For sure.
It's really shifted my perspective on how we can design and implement these systems in a way that prioritizes human understanding and collaboration.
It's been a pleasure diving into this research with you.
Likewise.
It's research like this that really highlights the exciting possibilities that are out there.
Yeah.
As we continue to kind of blur the lines between the physical and digital world, and who knows what other fascinating insights await us as we explore these uncharted territories.
I, for one, am excited to see where this field goes next.
Me too.
And to our listeners, if any of this has sparked your curiosity, we encourage you to explore related research on human-robot interaction, AR shared mental models.
You might be surprised by what you discover.
Keep those minds curious, and until next time, happy exploring.
Happy